Mark P. Otten back with you.
Okay, so just two more scenarios for you. Since there exist two more scenarios for two-way ANOVA situations, in that we just covered independent samples, two-way ANOVA. Both IVs were independent samples. Now I've kind of tweaked the example a little bit to match a two-way mixed ANOVA. A mixed ANOVA implies that one independent variable is of independent samples, and the other is of dependent samples. So I kept the participant gender variable as the independent samples IV. In this case, the males and the females participants are independent of each other. But then I decided to switch the other one to a dependent samples IV, and what that means is, in this case, keeping the same participants for, let's say, time 1, and then bringing them back when they're exhausted, and having them do another round of jumping jacks at time 2. So the time IV then is dependent samples because it's the same participants at each time point. And the dependence there would be, suppose you have a super athlete come in at time 1, they're more likely to then do more jumping jacks at time 2 than someone else who is not an athlete, let's say. So there's some dependence in that one person's score at time 1, time 2 might be dependent on whatever they did at time 1, and so on. Okay, so this is what the means look like according to this small sample example. Again, 3 people in each group, number of jumping jacks, the dependent variable. You see the data entered in SPSS, and then the means there in Excel. So the means for females, again, were higher, 25. That's probably the same group, actually, that participated before. So 25 people, or 25 jumping jacks on average for female participants at time 1, dropping to 16 at time 2. For males, there was an average of 5 at time 1, dropping to 4.67. So your marginal means there imply differences, right? You've got males and females here, female participants doing far more jumping jacks on average than males. And for time, it looks like the mean is dropping slightly from time 1 to time 2, so you would say that there appear to be main effects of each independent variable. Then for the interaction, you would do the subtraction, so you'd go 5 minus 4.67 for males. That's going to give you a value of about 0.33. Let me do that. Equals 5 minus 4.67. 0.33 is your difference score, let's say difference. Sometimes these are called simple effects. I'm not going to use any term. You can call them whatever you want, but I'm subtracting the two values in column 1 from each other. And then the same thing for column 2. If you go 25 minus 16, you're going to get 9. And so those values are different from each other as well, so that implies that there is an interaction there as well. And in words, what that would mean is that males are staying relatively consistent, right? From time 1 to time 2, 5 to 4.67, not much of a difference. But for females, they're dropping significantly because they couldn't keep up their record pace of 25 jumping jacks per person on average at time 1. Okay, so if these are based on means of 3 people, then you go over to SPSS, you see the actual data for the 3 people. And so this is, again, data was entered by way of variable view and also by way of value labels. So I labeled 1 as female again and 2 as male, as you see here. So then if we go back, we can see the 1s and 2s there. We can switch them to females and males in the labels. And we see the 3 people in each group. So there's 3 values in each group, but since it's a mixed design, you're actually getting the same people at time 2 as you did at time 1. So actually you only have 6 people total in the experiment, whereas you had 12 before in the independent samples example. But still the same amount of data, right? Three jump values of jumping jacks in each category, but only 6 people in this case as opposed to 12 in the previous case. All right, so there's your data. You just got to make sure that you're labeling your females and males properly, and then you're actually just going across jumps 1 and jumps 2. That's time 1 and time 2. And this follows the general rule of thumb for SPSS that each participant is a row, right, in your data set. So row 1 here is participant number 1, row 2 is participant number 2, and so on. So if you're doing a mixed ANOVA, you can look for this format here. And the mixed ANOVA, again, is a two-way ANOVA with one IV independent samples and the other dependent samples. Okay, so we're going to go to Analyze, General Linear Model, and Repeated Measures this time. Repeated Measures designates that at least one of the independent variables is a dependent samples IV. So for the mixed case in this one, we're going to use repeated measures, and for the dependent samples two-way ANOVA to follow, where both IVs are dependent samples. Then we're going to go back to the same place again. So for repeated measures ANOVA, you start out, or a dependent samples ANOVA in this case, you're going to start out with naming your factor. So in this case, this is your within subject factor name. What that means is you're going to name your dependent samples IV, in this case time, and number of levels is how many time points there are, so that's 2. So if you were to say participant gender here and 2 levels, you would be incorrect because participant gender is your independent samples IV. So here in this step, you're naming your dependent samples IV, in this case time, with 2 levels. You click Add, it drops down to this box here, which confirms that it exists for your study, and then you're going to click Define. And so in this case, you're going to put jumps 1 and jumps 2 over to the within subjects variables box, and that's going to be then in parentheses there 1 and 2 to denote the first and second levels of that variable. Participant is your between subjects factor. That's your independent samples IV, so that goes into the slot below. And then you want to click some of those same options that you clicked before. So we're going to click on plots. I'm going to put participant on horizontal axis and time on separate lines. You can again flip those if you want, but either way it's going to give you that parallel lines graph, or the graph, I should say, that will allow you to judge whether the lines are parallel or not. So if you do that, you're going to click Add, and it's going to appear in the box below here. I'm going to click Continue. And then I like to go to Options and save the descriptive statistics as well, so I can confirm whether my means in Excel are indeed calculated correctly, which SPSS will confirm for us here as we click through. So click Continue, click OK, and you're going to get your output. So that descriptive statistics box here shows you the means, and they're in a slightly different form, but they should match what we have in Excel here. Slightly different form in that they're organized slightly differently. They also give you standard deviations, by the way, for each box, which is, well, not really that useful in this case. Never mind. All right, so the output here is a little bit greater in quantity, so you just need to sift through it. It separates out your dependent samples IV from your independent samples IV. And so we start with the test of within subjects effects for interpretation here. This is evaluating your dependent samples IV, which is time. And so we're just going to go across to the first row here, sphericity assumed, and your p-value, which is at the end here under the sig column. 0.409 is your p-value for time. That's your that's your main effect of time, main effect of your dependent samples IV. So in this case, we had 15 and 10.335 for our marginal means. We said there's a difference in that it looks like time 1 is greater than time 2 in means, but the difference wasn't that great. And so in this case, it came out to be a non-significant interaction, 0.409 greater than 0.05. And so even though those means appear to be different, there is no interaction. No main effect for time. In this case, 0.409. Got slightly ahead of myself because the interaction is next in this box, time star participant with sphericity assumed there, the top line, 0.440 for your p-value there, greater than 0.05 again. So even though we observed some subtracted differences here, 5 minus 4.67 was a small difference for male participants from time 1 to time 2, whereas the 25 minus 16 was a bigger difference for female participants from time 1 to time 2. Even though there was that contrast there, the interaction came out to be non-significant, and so we cannot say that time and participant gender were significantly interacting here to produce effects on the dependent variable number of jumping jacks performed. However, for the tests of between subjects effects here, we've got the participant main effect hidden away down here. The line that says participant, if you go across, this one is 0.046 for a p-value. The corresponding F was 8.197 in this case. The p-value 0.046 is just barely below 0.05, so if you go back to the table, the 4.835 there for male participants was indeed significantly less than the 20.5 for female participants. And so we do, in fact, have a significant main effect for participant gender in that the females did more jumping jacks than the males did. Okay, so that's where to find your key results there. And then we go down to the plots here. We're going to see two lines. I explained this earlier in the video, how to plot these lines from your four means, original four means from your 2x2 table over here. So we can see that the lines are not parallel, but they're kind of close to parallel. I don't know. There's no the only real way to judge this is to go back to the p-value. The p-value said that the interaction was not significant. So the lines in this case are not parallel. That implies that there may be an interaction, but then the interaction itself was not significant. And so maybe you say something like the lines were not significantly different from parallel, which is sort of the graphical interpretation of the situation.